In this video, we are going to take a look at correlation matrices in R, and also along the way, I'm going to show you how to use a script. Now, a script is just a collection of commands, which you can save as a text file. A script is a text file, and this is helpful when you're going to want to go back to the work that you've done previously, and also when your commands start getting a little long, it's easier to use a script than to use the console. So to create a script from scratch, you can use the RStudio menu by going to the File menu option, or you can just go up to this little plus sign here, and then you can see our script is the first choice. You open that up, and here we have a blank text file. So for this video, we are going to look at a data set within the car data package. And you can see, because of my previous work, I already have these loaded. I'm going to unload them just so I can show you how to use the script as part of this. And I could just click those buttons down there, but I'm going to show you how to do this in the script. We've got the library function, car, and you can see that down in the console, nothing has happened. So you actually have to run the commands one at a time. So you're creating the commands, and you can see they're somewhat color-coded. But in order to run them, you have to hit this run button. And it'll run whatever command your cursor is currently on. You can also use a shortcut, like on the Mac. Instead of using the run button here, you can hit Command Return. And that's a little bit faster if you've got your hands on the keyboard. And I think it might be Control Return or something like that on a PC. But I'm going to, for this purposes of this video, just use the run button so that you can see what I'm doing. So I ran library car, which not installed, but loaded both of these packages. Okay, so within this car data package, we have a data set called Davis, which has heights and weights of about 200 people. So I'm going to go ahead and create that command and then run it. And now I'm going to view that data set. And again, if I just hit enter, the commands are being created, but I need to actually hit the run button to execute them. So here we have 5 variables: the sex, the weight, the height, and these weights and heights were measured using scales and whatnot. But people were actually asked to subjectively report how much they weighed and how tall they were. Now, if we just try to run a correlation matrix on all these variables, it's going to give us an issue because it's not going to like this categorical variable of sex. Let me show you that. So I can use the core function to get all the correlations of the variables in the Davis data set. But if I run this, it's going to give me an error because one of the variables is not numeric. So what we want to do is have run the correlations among these 4 variables, but leave out this variable. And in order to do that, we can just adjust this so that it has a -1 in brackets after the name of the data set. And that's telling R to ignore, not delete, but ignore the first column of data. Okay, so if I rerun that, now we have something, but we've got some problems here. So we have a correlation here between height and weight. And the issue is that we have all these NAs. Now, NA means not available. That is the code in R for missing data. So it's telling us there's some missing data for some of these variables. Essentially, reported weight and reported height have some missing data. I can show that to you here. So if we scroll down and we look at these numbers, we can see that there's some missing data here for cases 47 and 48 and 55 and 57. And so as a result, by default, the core function in R is not computing the correlation for any 2 variables where there's any missing data whatsoever. And so the only thing that it's giving us is the height and weight correlation because there's no missing data for these two variables. What we want to do instead is get a correlation for each pair of variables and just for any given correlation, leave off any observations for which there are missing data. So for example, for case 47, we wouldn't use that case for anything but the correlation between weight and height. For any of the other correlations, this case would just be ignored. So the way that we do that is we would create a different version. I'm just going to retype this here so that you can see what's added. So far it's just doing the same thing, giving us all the correlations minus the first column. But we want to use the use argument to tell R that we want pairwise complete observations. And that basically says use as much data as you can, but ignore any observations that have missing data when you're calculating your correlations. When we run this command, we can see now we've got a full correlation matrix. We've got weight and height, weight and reported weight, weight and reported height, and so on. So just be aware that when you're using the core function to get all the correlations, these are two things you can run into. First of all, there might be a variable or more than one variable that you can't really include, and so you have to tell R to ignore it. And then just by including this here, it tells R basically to work around any of the missing data in the data set rather than just reporting back that it didn't calculate the correlation.